I would tell them to get out of their head.
Be stubborn.
Just be more confident in your abilities.
Build your intuition.
My advice would be to get over your ego. At the end of the day, we're all here just trying to learn.
And get over your fear of your professors, because they are your best resource and they really just want to help you to succeed.
I personally think people have a notion that you have to be smart. I don't think you have to be smart. I just think you have to work hard.
All you need is hard work and a little bit of smarts, but mostly hard work. So just be confident in what you can do and try really hard.
What will really help you with your later engineering classes is when you have an understanding in reality, a bit of an intuition for how things work. So if you're used to taking things apart and putting them back together and working on machines and creating and working that creative side of your brain, that problem solving side, it'll help you so much.
Be humble and go into your professor's offices and say, I don't understand this, can you help me? And that will get you so far, more so than trying to struggle with your own on something. Just ask for help and it's not the end of the world, I promise.
I chose engineering because I like to work with my hands, and I figured that if there was one thing that I wanted to do for the rest of my life, it was take things apart and figure out how things work.
I originally thought I wanted to do architecture. So I thought engineering would be a cool way to make more money and kind of do some architecture because I'm civil engineering, thinking more structural engineering. But now that I've gotten into it, I really enjoy it. I love the idea that I can calculate all the loads on a building, figure out everything you need to with building codes. I find that super fun and super rewarding.
I chose engineering, as a lot of people do, because they like taking things apart. I'm a very tactile person, whether that was taking apart my dad's computer stuff and getting in trouble for it, or figuring out how to build a bow and arrow. I like to have my hands on things, so that's why I chose engineering.
Engineering at Walla Walla, you're actually technically getting a Bachelor's of Science in Engineering, and then it's some concentration in civil, mechanical, electrical, bio, or computer. And the cool thing about that is you get a wider background. So for me, like, I've taken some electrical classes, I've taken some programming, I've gotten a chance to dabble in other areas of engineering that you might not as much if you were in a more focused career line. And where that's really useful for is if you want to go and work in a position that's more in leadership, or in a position that's integrates and talks a lot with different disciplines in engineering, because you have that foundation for communication right from the get-go.
The professors, they are incredible, and I really enjoy that they start each class with prayer, and they really care about their students, like not only in your classes, but they care about your personal lives and how you're doing.
They teach you how to work well with other people, because I think it's a misnotion that engineers are smart and socially awkward, but our department does a good job of teaching you that, yeah, you have to be smart, but you also have to know how to work with people.
I think what's unique about the program at Walla Walla is the class sizes. I haven't been in a class with more than 30 or so students, and that really allows the professors to have one-on-one time with the students. At this point in my senior year, I feel very comfortable walking into any of my professors' offices, asking questions, sitting down, and really making sure I understand the material. So that's what I would say is unique.
I don't know where else you would find professors as dedicated to helping you as you would at Walla Walla. They're up all times of the night for emailing for help. They're so dedicated and they really invest in your success.
What I love about our engineering department is they sort of just get you hands-on very quickly. So my first year, I built a truss, a 3D printer, and I made a project where I made a pulse jet on CAD.
I really enjoyed it. The classes definitely get better the further along you get, as you get more ingrained in the details and how to design things and how to apply all the math and science you slog through the first 2 years.
Well, I took a class last spring. It was civil engineering materials, and basically the whole class was just making projects and then destroying them. So I thought that was really fun. Like, we would make like these huge like concrete cylinders, and we get to crush them in like this big machine and like analyze how it cracked and the loads it could take, and then we try different ingredients in the concrete.
My favorite class and favorite lab would probably be fluid mechanics. You do a lot of learning about how air flows and how like jet engines work and stuff like that. So you're learning a lot about how mechanics of how fluids work.
My favorite project that I've done to date is from a class called Manufacturing Systems in Engineering, and we had to work in a team of 4 to build a automatic syringe changer for a bioprinter. So we had to start from the concept of the design, how we're going to accomplish the objectives, all the way to having a demo of our project at the final exam time. So it was really kind of the full circle cycle of a project, and it was really neat to be able to kind of think through the whole process and have something to show for it at the end.
Actually, this year, I'm working with a local company that manufactures transport tanks for fish, as well as emergency shower enclosures out of fiberglass and composite materials. And it's been really interesting to tie together the knowledge that I'm gaining from my composites class that I just finished into my capstone project. So I can use the knowledge I gained to analyze the materials that they use to construct their products.
Hi, my name is Talia Nelson. I am the STEM recruiter and engineering program coordinator at Walla Walla University. I'm very sorry that you guys can't be physically here, but we want to give you a tour of Kretschmar Hall. Kretschmar Hall is the place where engineering happens, math happens, physics happens, and community happens. So a lot of students come here for their classes, but they come here to study and hang out with other people and be around each other while they do their classes and do their homework and that sort of a thing. So we're going to walk you through Kretschmar Hall, and we hope you guys enjoy this tour. So this is the structures lab. This is where civil engineers come to crush heavy and big objects. We have a 10-ton crane that can carry around big concrete blocks, and engineers will test these concrete blocks to see what their structural capacity is. So a lot of crushing happens in this lab, a lot of breaking, and a lot of really interesting stuff that goes boom. So Dr. Nelson is here with us, and he's going to talk to us about what happens in the digital electronics lab.
Hi, we have lab in here and use electronic equipments when we're done playing ping pong. Sorry that you folks can't be here, we miss you. But if you were to come here and study electrical or computer engineering, you would get to spend a lot of time in this lab. You can see we have a lot of lab equipment set up, primarily for junior and senior engineering students. It's very capable stuff, industry standard. We train our students on the same equipment they're likely to use when they graduate. So it's a three-dimensional light cube where students will interface this to a computer, and it can do a 3D image from what's on the computer. For instance, it can take a person's face and portray it with the different LEDs. There's various different color ones. We look forward to seeing you wherever you are. Okay, back to our game.
So Dr. McKenzie is our resident bioengineering professor.
So, if you come to Walla Walla University, we have a wonderful Department of Engineering, and one of our programs is bioengineering. We have tissue engineering, biomaterials, bioreactors, all sorts of fun courses like that. So I am currently in the biomaterials lab, and we have some exciting pieces of equipment to work with here. This is our electrospinning machine, created by students and used by students to create biomaterials for potential implants into the body that would become tissues after they broke down. So we also have the second generation bioprinter over here, which also creates biomaterials for the body. Both of these machines have voltage sources that we can apply. This helps us to be able to control the fibers better and make them smaller. And so these are a lot of fun, not only for class and labs, but for student research projects. So this is just where we mix our polymers to go ahead and print. And I can show some examples of things that we've electrospun and printed. And these fibers are about 5 microns in diameter, and yet you can see we can fairly controllably place them, which is amazing. That this is a great technology. There's not a lot of people that are able to controllably place such small fibers.
So we're here with Dr. Roth in the Mechanics of Flight lab. Dr. Roth is our resident flight expert, so he'll talk to you a little bit about what happens in this lab.
Hello and welcome to the Flight Lab. I'm excited to share some of our work, some of our projects here. I'll start by pointing out a couple airplanes that are hanging here from the ceiling. The first is right over my head here. It's a class project built by some of our students. The goal is to make a very light airplane on the order of 4 or 5 or 6 quarters. That's how light it is. And so we start with a very small motor. I have an example of one here. Smallest motor I could purchase to make the project more challenging. And then we have a variety of challenges that students complete using that airplane. The second airplane I'd like to highlight is the one just overhead here. That's a senior project built by a team of senior mechanical and electrical engineering students. Our mechanical engineering students focus on the airframe. What you see here, what you don't see is inside, the brains of the airplane, and our electrical and computer engineering students focus on that. And we've had a variety of missions, things like crop mapping, so sending our airplane autonomously to take pictures of a crop and then stitch those together to create a mosaic. We've done autonomous thermal soaring, is another mission. We've done collision avoidance. Each year we have a new mission together with some industry sponsors. Our project this year is sitting in pieces on the back table here. I'm excited to see it. We are trying a different construction technique focused on using wood. Wood's not a typical aerospace product, but using balsa wood, we're actually able to model a typical structure that you might find in a much larger aircraft. So it's a good experience for our students. All of these parts, this would be an example, all of these parts are cut on our laser cutter. They were designed in CAD, computer-aided drafting software, and then printed using our laser cutter.
So we're downstairs in the manufacturing and robotics lab. This is Professor Sterling's lab. So here we have Mike the Mill. Mike the Mill is a very big, expensive piece of machinery that we brought into this lab to make parts that look like this. And then moving forward here, we have a CNC lathe. So lathes make parts that are turned by like a rotating process, so they make parts that look like this. These are two really awesome pieces of machinery that we're really lucky to have downstairs in this lab with us. This lab was also used for robotics class. So the project this year for robotics class was for this robot arm to come down, grab a syringe, press down on the plunger, release it, and then put it back in a little container over here. And this is used for the bioengineering students in the tissue engineering lab. So there's a lot of cohesiveness between each lab in this department. So we're here in the 3D Concepts lab. So in 3D Concepts, we use 3D printers to make parts that look like this. So this part here was printed from the inside out, and it is all one cohesive print. So we have multiple printers in this lab. This is actually a student-built printer. Every year, the freshmen construct a printer together on a team. And this printer itself was actually designed by a Walla Walla University student, and they made the entire kit. And then students actually build this printer every single year. So it's a really cool project. All the rest of these printers in here are actually used to print parts for community members. So in this 3D Concepts lab, we have a couple of people that actually work as employees that do contract work for the community. So community members will come in and say what they need and like what kind of price range they're looking for, and engineers will actually quote them with different prices and stuff. So it's like a really cool business that engineers actually self-run.
Thank you for joining us for our virtual U Days. It's been great to show you around our engineering labs. We hope to see you here on campus soon.
We just wanted to let you guys know that we do have a Walla Walla Engineering Instagram page. You can feel free to DM that account if you have any questions at all. It's at Walla Walla Engineering. And I also want to encourage you and let you know that you are more prepared than you think you are. So if you get on campus here at Walla Walla, just make sure that you believe in yourself and that you're confident, and we're here to answer all your questions. Thank you.